Let's go ahead and do some examples of solving some equations now with variables in our exponent. I guess we can call these exponential functions. Now, like we talked about in class, the whole key to solving these kinds of exponential functions, especially when you have exponential function on both sides of your equation, you have to make sure that the bases of both exponentials are the same. If the bases of both exponentials are the same, then we're able to solve it. So this first example, I've already written 7 to the x plus 6 equals 7 to the 3x minus 4. So I have two exponentials here, and they both have a base of 7. So since I have the same base, the only way these two exponentials can be equal to each other is if the exponents are equal to each other. So I'm simply going to set x plus 6, the exponent of the exponential on the left-hand side, and I'm going to set it equal to the exponent on the right side. So I can simply write x plus 6 equals 3x minus 4, and now this is a linear equation that I can solve for x. I'll go ahead and subtract x from both sides. So I get 6 equals 2x minus 4. Add 4 to both sides. Two x equals 10. Divide both sides by 2. And your solution is x equals 5. And if we want to take the time, if I plugged in x equals 5 back into my original equation, it should work. I'd have 7 to the 11th on the left-hand side. The right-hand side, 15 minus 4 is also 11. 7 to the 11th, yes. We have done it properly. Let's look at another example. How about 4 x to the minus third equals 8 to the 4 minus x? Okay. I've been saying all along, if we were to solve an equation like this with two exponentials, we have to make sure the exponentials have the same base. Well, for this problem, on the left-hand side, we have a 4, and the right-hand side, we have an 8. Those bases are not the same, therefore, at this point, we're not able to really solve it. So the goal would be to somehow try and rewrite these exponentials so that they have the same base. And this is where, if you do these problems enough, you just sort of get a knack for it, and you start figuring out what to look for. So for instance, if I think about it, I can rewrite 4 as an exponent. 4 is 2 squared. So instead of 4, let's write 2 squared. Of course, 2 squared is going to be raised to the x minus 3. I'm simply replacing the 4 with 2 squared. 2 squared equals 4. And on the right-hand side, I realize that 8, I can rewrite as an exponent of 2 cubed. So instead of writing 8, I'm going to write 2 cubed. But of course, it's 8 raised to the 4 minus x power. So I have to raise my 2 cubed. I have to raise it to the 4 minus x power. Now, looks like I have the same base, but I need to do some work on these exponents. Hopefully, if you remember, one of our product rules says that if you take an exponent and you raise it to another exponent, what do you do with these exponents? In this case, you multiply them. And just to be very clear, I'm going to put parentheses around the x minus 3 and the 4 minus x because I'm going to have to multiply by the whole thing. So this is going to be 2, and the exponent is going to be 2 times x minus 3. So if I use my distributive property, it would be 2 to the 2x minus 6. And the right-hand side, I'm now going to multiply 3 times 4 minus x. So the right-hand side would be 2 to the 12 minus 3x. All right, so now I've achieved my first goal. These exponents have the same base. And now when I have this situation, it's fairly easy to solve. You simply set the exponents equal to each other. So I'm going to say 2x minus 6 has to equal 12 minus 3x. And now it's a matter of solving this equation for x. I'll go ahead and add 3x to both sides. Get 5x minus 6 equals 12. And then let's add 6 to both sides. 5x equals 18. If I want to solve for x, divide both sides by 5. X equals 18 over 5. Not a very pretty answer, but it is correct. If we wanted to, we could take the time to plug x back into the original equation and it would work. I'm not going to take the time to do that now. Let's do one more example. Our third example, let's go and solve 1/2 raised to the 6 minus x equals 2. All right, this looks a little different. In the first case, if I look at the right-hand side, there's not even an exponent there, it's just 2. Well, yeah, that's sort of true. At least we can't see the exponent, but there really is one there because there's really an exponent of 1. Of course, normally we don't write an exponent of 1. And then you stick it there for this problem just to make it clear to see. But now I have 2 exponents, but now I have to compare and see if they have the same base. They do not have the same base. On the left-hand side, I have a base of 1/2. On the right-hand side, I have a base of 2. Well, once again, this is the kind of problem that with experience, you sort of begin to see how to do these kinds of problems. Because what I'm going to do is, I'm going to realize that, if you remember back, property of negative exponents, 1/2 is the same thing as 2 to the negative 1. In other words, if I put my 1 here as the exponent on 2, you know a negative exponent causes it to flip, go from top to bottom, bottom to top. So if I sort of go backwards and I, in a sense, create a negative exponent, I realize that 1 over 2 is the same thing as 2 to the negative 1. In other words, just to convince you, what if I gave you 2 to the minus 1 and said, please write that without a negative exponent? You would simply say, well, that's 1 over 2 to the first, which is 1/2. All right, so hopefully you're convinced now that 1/2 equals 2 to the minus 1. So I'm going to replace this 1/2 with 2 to the minus 1. Of course, the exponent is still 6 minus x, and the right-hand side is 2 to the first. All right, so I'm making some progress. Looks like I have the same base now of 2 and 2, but the left-hand side I need to simplify some. 2 to the minus 1 raised to the 6 minus x power. I'm going to have to multiply the minus 1 times the 6 minus x, and you end up with 2 to the negative 6 plus x equals 2 to the first. So now it's pretty clear with my common exponent of 2, negative 6 plus x has to equal 1. If I add 6 to both sides, I get x equals 7, and that should be my solution. So solving these equations with two exponents, hopefully you will find not that difficult.